Hey guys, and welcome to a new video. In this video here, we're going to take a look at the new framework from Roboflow called Autodistill. It is basically using like the foundation models like segment anything and also grounding dino to go in and label your dataset automatically. You don't have to do anything. We'll just have a dataset, a custom dataset that we want to train an object detector on. We basically just have the images. We don't have to label them. We throw them through the Autodistill framework. It will label the images for us, and then we can go in and train our own custom object detectors like a YOLOv8 model on our own custom dataset without doing any labeling. So let's now just jump into the GitHub repository and take a short look at it before we're going to jump into our Google Colab notebook, where we're going to go over, we have a custom dataset, how we can set it up, how we can label it with these foundation models, label our dataset, train a custom object detector with YOLOv8, and then we can use that to run inference on our edge devices or on our computer. I have videos about all of those different things. I also have courses with my YOLOv7, also my YOLOv8 course. We both cover object detection and object tracking in those. But here we're basically just going to take a look at the GitHub repository. Autodistill uses big, slower foundation models to train smaller, faster supervised models. So they're basically just using like grounded dino together with segment anything to go in and do few shot and zero shot learning for these object detection models. Here we can just like scroll through it. This is the example that we're going to use. So this is an example output where we're going to detect these milk bottles in a production line. So this is a very nice and useful specific case that can be used in a real life scenario for a production setup where we want to detect these milk bottles in a production setup on these conveyor belts moving around in the factory. So this is a really cool one. We basically just have a data set with all the images. We have no annotation, no labels for all of these objects. We will just throw it into Autodistill framework, and then we can train our own custom object detector with the YOLOv8 model to go in and get these nice results. So we can see we have some different kind of like features, pluggable interface to connect models together, automatically labeled dataset. So this is really, really cool. We don't have to spend a lot of time actually labeling our dataset. We can just do like faster prototyping. We can do a lot of different kind of stuff with this new cool framework. Train fast, supervised model. We can own your own model, deploy distilled models to the cloud or to the edge. So we're basically using these large foundation models that understands like complex scenes going on, like complex objects in scenes. It can actually just learn that there's a milk bottle in the image. We don't have to do any labeling. It just knows like how it looks like. Then it uses the segment anything model to go in and get the actual bounding box and also the segmentation mask. So this can both be used for segmentation problems, but also for object detection. So we have the basic concepts here. We won't really go into that. We have the task, we have the base model. So these large foundation models is used as a base model. We also have this ontology, which is basically just a mapping from the classes or like what we actually want to detect to the classes for our dataset. We will create a dataset, and then we can have this target model at the end and also a distilled model for the final output. Here you can read a bit about like the theory and also the limitation. Again, we have the base model with the grounding dino, SAM, and detect here. And then we can go in and train like YOLOv8 for instant segmentation, object detection. We can also train all the other different kind of like target models that we have. So this is a really cool framework. We don't have to spend any time on actually like labeling our images, especially if you just want to test some different like data sets out. If you have a video of a production line, you can basically just extract all the images, use it with this framework here, train your own custom object detector, and then you basically have like a deep learning AI model running. Here we can see like how we can install it. We're going to go over that in the Colab notebook as well. We can also see like how we can distill a model here in a custom Python script. We're going to do that in another video. So in this video here, we're just going to see how we can train it. Then we're going to create it with our own custom Python scripts in other videos. We can also visualize our predictions here. Down at the bottom, we can see like object detection with grounded SAM, grounded dino, and then also all the different kind of like target models up here at the top. So DTR, YOLO Nash, YOLOv8. So we have all these new state-of-the-art object detection models and also instant segmentation here with YOLOv8. So this is really cool. Okay, so we're not jumping into the Google Colab notebook. We're basically just going to scroll through it. I'll explain like what's going on and how we can use it on your own custom data set. Here in the start, they basically just have something like what is the framework. We basically just went over that in their GitHub repository. So we're basically just going to scroll through that. First of all, make sure that you choose the runtime. You use the GPU here in Google Colab. So here I'm going to use this GPU here. We can also choose the GPU version that we want. So I'm going to go with an 800 because I'm on the pro version of Google Colab. We're also going to choose high RAM down here at the bottom for our runtime shape. Then we're going to connect to our runtime and we can go down and actually run our code blocks. So steps in this tutorial here, before we start, we have our image dataset preparation. We're going to auto label the dataset, train the target model with the YOLOv8 model, evaluate that model. We're going to see the results, so the training graphs after we have trained the model on our auto labeled dataset, and then we're going to run video inference. We can also upload our dataset and model to Roboflow at a later point, but in this video we're going to see how we can do video inference. We're also going to export the model, and so before we start, we're going to have this NVIDIA SMI, so we can see all the details about our GPU. So again, we have this NVIDIA 800 GPU available. I'm just going to zoom in here a bit so you guys can better see what's going on. So here we can basically just see we have this NVIDIA GPU. We can also see the number of megabytes we have in our RAM. So here we can see we have 40 gigabytes of RAM in our GPU, which is really good. So let's not just scroll down and install Autodistill and see how we can set it up. First of all, we're just going to pip install it. So we're going to pip install Autodistill grounded SAM, and also Autodistill YOLOv8 supervision for visualizing the results later on, both from our grounded SAM model and also our target model with YOLOv8. So here, first of all, we're just going to install it. After this is done, we can basically just go down and get started, trying out doing auto labeling of our dataset. So this might just take a couple of minutes, and then it's actually just set up. So down here, we're just going to import our OS. We're going to get our home directory on Google Colab here. So let's just do that. We're just going to run it. So right now we're in our home directory, which is our content directory. If we go over here to the left, this is basically our content directory. So now we can go in and do image dataset preparation. We're just going to create a directory called images, where we're basically just going to download our videos or like our images to, and then we can use those to feed into our grounded dino model, the same model for actually labeling our dataset. So let's just go in and create a directory. We should be able to see it over here to the left. So here we have our image folder. So here we can download raw videos. If you have your own dataset, you can basically just skip these steps. You will also already have like all your images inside your dataset. So this is basically just for like downloading a video. Also, if you have a video, you can use that as well. And then we're going to convert our videos into images, basically just extract our images from our video that we can then use in our dataset to do auto labeling. So I'm just going to create a new directory here. So we're going to create this video folder. We're going to cd into it, and then we're going to use vget to go in and download this video from Google Drive. We're going to unzip the video. So we also over here to the left, we should be able to see our videos. So we have this video, and then we have the different kind of like videos down here at the bottom. So we have these milk bottles that we want to detect in our image, as we also store on the Roboflow GitHub repository. Now let's just scroll down. We can then convert our videos into images. We're just going to create our paths, or like set our video directory path and also our image directory path. And then we can go down and basically just extract all the images from our video. So this might just take a couple of seconds as well. After that, we can go down and display an image sample from our dataset. So let's just visualize what we actually have in our dataset. So first of all, we just need to wait until this has finished. So it took just around like 1 minute to actually extract all the images from our video. And before we're going to build a model with Autodistill, we just verify that we actually have everything stored in our folders. Let's just go up and verify that as well. So here we have just extracted all the images from the video inside of our images folder. So over here to the right, we should be able to see an example when it has loaded. So this will be one of the images that we're going to feed into the Autodistill framework and do auto labeling of these milk bottles and also the caps on top of the milk bottles. So again, this is just really cool that we can do this. We don't have to like label our images. We just have a single video, throw it into it, extract the images, and then we can do auto labeling of our dataset and even train like object detectors on that. Have a video, just tell our model, I want to detect milk bottles in this video, and then we get the detections. We can use it to train our own custom models. This is just really cool. So just go down and display an image example. So image count, we have 132 images in our dataset. Let's go down and visualize it. Here we're just going to plot like an image grid of all the images, or like some of the images that we have in the dataset. And here we can see some of the examples from our dataset. So we just went over like one of them, but we can see we have all these images with milk bottles and also the caps extracted from a video of a production line with these milk bottles. So these are some pretty good images. Let's now see how we can actually use Autodistill to also label our data set. So first of all, we're going to define something called an ontology. And ontology is basically just like how our base model is prompted, as it also says here, and also just describe what you actually see in your data set and what you want to train your target model on. So this is basically just like the mapping from the prompts to the actual like classes that you want to detect. So in this example here, we're going to prompt it with milk bottle, and then the class for our target model will basically just be bottle. And then we're also going to prompt it with blue cap, and then we're going to map that to a cap in this data set. So we're going to have two classes in our data set that we want to predict, or like two classes. So we have our bottle and we also have our cap. Then we can initiate a base model down here and do auto labeling. I'm just going to run this first of all because we have to define this ontology. This is one of the things that we need to specify. We also have the base model, target model, and all those different things that were listed in their GitHub repository. Then we're going to set our data directory path. And now we can go in and use Autodistill _grounded SAM. And then we can import a grounded SAM. We set up our base model, and then our base model is initialized with our ontology for the different kind of like classes. So we throw in the prompts, we get the classes out, and then we can label our data set after that. We're going to create an instance of our base model, and then we can just set our data set equal to our base model dot label. So to have a method called label that we can directly call on our base model. We throw in the input folder. So this is the path to our image directory, the extension of our images. So we're going to use PNGs, and also the output folder where we want to store our data set. And we're also going to just return our data set here. And this data set here is basically like our whole labeled data set. We only need to initialize this grounded SAM model. It will do anything for us. We just need to initialize it with our ontology as well, our prompts for how it should label our data set or also label our data set. So this is just really cool. Like we import it, initialize the model, and then we can just call this label method and it will do everything for us. Like this is groundbreaking. This is definitely going to save a lot of time in the future. It is just so cool. So here we will have our data set. Let's just run it and see it. We'll have our data set. We also have our output folder, which is set equal to the variables that we set up at the top. So trying to load grounding dino directly, downloading dino model weights. So this might actually take some time. We have to first of all download the weights, throw it through, like throw all the images through it, also label them and so on. So here we can see that it downloads the model. So it might take some time here. So that was it. Now our whole data set is also labeled with this new Autodistill framework. So again, it took like around a couple of minutes, so maybe like 3 to 5 minutes. Now we have all our images labeled. We have 132 images labeled. Let's just go over here. We have our data set. We have all the annotations. So let's just open that. We probably shouldn't do that with 132. We also have our images. We have our train and also our validation split. So we can go in and see all the individual images that we have in our data set. So now we have our whole data set also labeled. We just went through the whole Colab notebook here. We ran a couple of code blocks, and now we're actually here with our own also labeled data set. So now we can go down and display a data set sample. So we're going to set our annotations directory path, our image directory path, and also our data YAML path. So we're just going to set that. And now we can use supervision to go in and create the detections for our data set from the YOLO format. We basically just set up the different kind of like directories that we want to use, and we can set up a link for our data set, which should return 132 as well, which is the number of images that we have in our data set. So here we have 105 because we're only using the training images, I think. Yeah, that's correct. And now we also have supervision to go down and create our image examples. So we basically just have a for loop running through like all the image names, creating these annotation images with our mask and also the box annotator from supervision. And then we're going to plot our image grid again down here at the bottom with the samples that we have from our dataset with our auto labels. So it might just take some time here before we're going to see the results. Here we go. So now we have the images here again that we saw in the start. But these are just some examples. We have the video, extract them into images. We also labeled it with a couple of lines of code. And now we have these predictions. So we have our cap at the top here, which is the green marker here, or like the green segmentation mask. We also have the pink one here, or the red one, which is the milk bottle. So all these annotations here are automatically labeled with these foundation models. We basically just threw in the prompts, milk bottle and blue cap, and now we have these labeled images in our data set. This is really cool. These are some really great annotations as well. Like these are just perfect annotations from the segment anything model. So again, all these foundation models are from Facebook or like Meta AI. So again, some really cool models. We're just going to scroll through them to see a couple of examples. So again, it just does a perfect detection. It does a perfect annotation on all of these examples that we see. So we should have some good annotations that we can just directly feed into our YOLOv8 model, which is what we're going to do now. So now we have our target model. We're going to set up like the YOLOv8 model as we've been doing in all the other videos. I also have videos here on the channel where we go over how we can train our own custom data set with manually labeled images. Now we can just use this script, go through it, auto label it with Autodistill. So now we're going to see the entire home directory. We're going to import the YOLOv8 class. We set up our target model. We can also specify what model we want to use. So in this example, we're just going to choose the nano model for YOLOv8, and then we can call the train method. We throw in our dataset, YAML path, and also the number of epochs that we want to train our model for. And then we should be able to see, first of all, we'll get a summary of our model. We see the number of parameters. We also see all the hyperparameters for our training, the CUDA device that we're using, NVIDIA 800. So these are just all the parameters, all the hyperparameters for a model, the number of layers, parameters, and so on. And then we're going to see the training results down here at the bottom for our epochs. So here I'm basically just going to go over to the right. We're going to take a look at the mean average position. We can also see the box loss, the class loss, but the main ones here is basically like the mean average position. So let's just let it run here, let it train for a couple of minutes, and then let's take a look at the results. So our model is now done training. Let's just take a look at the results here, like the training results for each of the epochs. I'm not sure why we get 0 here in the mean average position of 0.50 and also 0.50 to 95. We might get some results later on, but we can also still see like the class loss here and also the box loss, which is decreasing over the number of epochs, which is good. Let's just scroll a bit further down. And now we should also be able to see, okay, so now we get the mean average position of 0.50 and also 0.50 to 0.95. So again, we get some pretty nice mean average position here. We also have the loss, it is decreasing over time, like the class loss is decreasing. It actually like looks pretty good. We can see that our mean average position still increases. We're around like 0.81, 0.82, 0.84 here. So again, this is actually like pretty good mean average position just by training on 130 images. So just remember we have 130 images or like even only 100 images in our training set. And then we're basically training our own custom YOLOv8 model from our auto-labeled dataset. Here we end up with a mean average position of 0.86, mean average position 0.50 to 0.95 at almost 0.79. That is pretty good. And we also have a good box loss and class loss. We can go down and evaluate our target model here. So we can basically just go inside our runs detection. So if we go inside our directory, we have a runs detect train, and then we can see all like the outputs here. So we both have our confusion matrix, we have the results and so on, but we can also visualize it directly in a block of code. Let's just do that. And now we should be able to see our confusion matrix. So in the diagonal here, we should have the most values because then we have our true positives, or like our true predictions. So here we have the prediction labels, and then over here on the x-axis, we have our ground truth labels. So we can actually see when we have the bottles, we do a pretty good prediction. We also do like the cap here, so the blue cap on top of the milk bottles. We actually have some pretty good detections for that. We can also see the results here for our basically like our training graph. So let's just take a look at those. We can see the box loss is decreasing over time, as we also saw when we went over the results in the epoch. The class loss decreases. We have our precision here, so it kind of just jumps from 0 to 0.80 here instantly. It kind of like converges here, is still increasing like slightly. We could probably increase the number of epochs and get slightly better results. We can also see that the mean average position down at the bottom here, it hasn't really like fully converged yet. But we have a pretty good model here, pretty accurate model that can actually go in and do object detection with our target model trained on our auto-labeled data set. We also basically just have a validation batch here, which is a prediction. So here we can see some of the results. This is the results from our YOLO model. We can see that it actually does miss some predictions here. It is pretty good at detecting like the caps. We can also see some nice detections of the bottles here, also here. Sometimes we get some false positives. We miss those detections here and also here. So we kind of like, we can't really like detect this scenario here. It seems like where we can see like the top part of the bottle, or the bottles are very close to the camera. We can also go down and just throw in a video. So we're going to just throw in the video that we trained our model on. So we're basically just going to take that video, throw it through the model, and then we can see the inference. So now we just call this predict method. We can just see that it just throws all the images from the video through the YOLOv8 model. We can also see the number of bottles that it detects, the number of caps, and also the inference time over here to the right. Then if we scroll down to the bottom, it is basically just throwing all the images through the model. The results are saved to runs, detect, predict, and then we can basically just create a video from that. So let's go over here to the left and just take a look at it. So we have our detect, we have the predict, and now we have an MP4 file. Let's just go in and download that so we can then see the results on our Axe-like video stream. So we'll take a look at the video here and see the inference results on this video. So again, we get some really nice results. We detect the bottles here in the foreground. We lose tracks sometimes, but again, we're only doing update detection in this scenario. The cups, or like the caps up here at the top, we don't really detect those. We just detect them as a single one. Sometimes we detect them on top of the milk bottles, but sometimes we also miss them, as we can see over here. So right now we can see that we take the cap, but with a low confidence score. This was actually like a pretty good detection, and also again we can still detect the bottles with a high confidence score. Again, just remember we only trained this model on 100 images. So these are some really nice results. So thank you guys for watching this video here, and again remember the subscribe button and bell notification under the video. Also like this video here if you like the content and you want more in the future. We're definitely going to use this Autodistill framework way more in the future. See you next video guys. Bye for now.